Hi, welcome to another video on my channel. In today's video, we're going to look at how to apply the chain rule again to a different problem, similar to another problem that we have on this channel on chain rule. Okay, so let's get started on this. So we have the function z, which is actually a function of x and y. So let me make which is actually a function of x and y, where x is given as where x is a function of s and t, and y is a function of what? S and t as well. Now we are going to find the derivative, the partial derivative of z with respect to s. Now, as well as that of s with respect to t. Now, if you haven't watched that video, the link will be in the description. It's part of the So it's part of the playlist for this particular problem solving series. So make sure you go and watch that video. It's timed the partial derivatives, right? So go and watch that video as well as this one, okay? So let's see how we can find these partial derivatives. Now, the first thing you have to note is z is actually a function of what? X and y. And then x becomes, z is a function of x and y, whereas x is a function of what? S and t. And the same thing with y. Y is also a function of what? S and t. Now, in order to find the partial derivative with respect to s, we need to use chain rule to pass through x before we can get to s, as well as passing through y before we can get to s. So, which means this partial derivative can be written using chain rule as what? dz del x multiplied by what? Dx ds plus the other route, which is from z to y and then y to s. The same thing we'll do for t. So in order to find this, we'll move from z to x multiplied by what? Derivative of what? X to t, right? Del z del y multiplied by what? Dy dt. So these are this is the chain rule that guides the solution of this particular problem. Now, what is left is to find all these partial derivatives and multiply them together and add those partial derivatives. So as easy as that. Now, let's see. For the problem we have, we know what z is. So what is del z del x? So this we need to find del z del x and del z del y. So we need to find these two. So the derivative of this with respect to x is just, here's going to give us 2x. Here would give us minus 2y. And the last term would give us 0 because the last term doesn't have x on it. Okay. What about del z del y? That would give us, the first one will be 0, second one will be minus 2. Okay, so I'm sorry, so I think there's a mistake here. It's supposed to be minus 2y. Oh, sorry, I think I conflicted that. Yeah, so the first one is correct. The first one is 2x minus 2y. Now the second one is derivative of this with respect to y is 0. For the second term, we have minus 2x, and the third term we have derivative of that with respect to y is 6y. Okay, perfect. Now everything is good. Now, in turn of this, we need to find the x ds, and then we also find the y dx, right? So let's do it here. Now, this is x, right? X is a function of s and t, right? X is what? st. Now, derivative of this with respect to s is just going to give us t. Now, what about dy ds, right? So derivative of y with respect to s is just going to give us, you can see it's just going to give us 1, and the other term will be 0. So it's going to be 1, okay? Now let's find del x del t, the x dt. If you check again, derivative of this with respect to t is just going to give us s, and then del y del t, which is derivative of this with respect to t. The first time will be 0, the second time will be 2. So this is all we have. And then we can quickly find what we are looking for. Now, del z del s is just going to give us dz dx, which is just 2x minus 2y, multiplied by dx dt, dx ds, which is t, plus del z del y. What is del z del y? Which is minus 2x plus 6y. Multiply by what? dy ds, which is 1. Okay, so all you need to do is just to expand this. This is 2xt minus 2yt, then minus 2x plus 6y. So this will suffice. Now, if you like, you can go on and substitute the values of x and y in terms of s and t. So what I mean is either you can stop here or you can go forward and say, okay, x is actually st and y is actually, what is y? I think y is giving us what? S plus 2t, right? S plus 2t times t. So I'm just substituting x and y into this equation. Then the same thing, st plus 6y s plus 2t, and you expand this. So it's either you leave your answer here, which is fine, right? Or you, if they ask you to make sure that what your answer is in terms of s and t, then you kind of substitute what x and y are into the equation. So in this case, you can just have 2st squared minus this times s times t, that will be minus 2st, then minus 2 times 2t times t, that will be minus 4t squared. Then you come here, you have minus 2st, then here you have 6s plus 12t. So let's see, can we collect like terms? Yes. The only two terms that are the same is minus 2st minus 2st, which is minus 4st. Then you have minus 4t squared plus 6x plus 12t. So this will be your solution in terms of st. In terms of x, y, t, and s, if you like, this would be the answer. So both of them are correct. So this is correct or this. Okay. Now let's move to the second one, which is del z del t. Now we know del z del x first, which is 2x minus 2y times dx dt, which is here, which is just s, plus del z del y, which is minus 2x plus 6y times dy dt, which is times 2, right? So we can expand this and have 2xs minus 2ys plus minus, so just to note, these two, you can bring it to the front. So that will be minus 4x, then plus 12y. So I'm using these two to multiply this, using these two to multiply this. Okay. So you have this, then you can just, so you can leave your answer as this, right? So this is quite correct. Or if you like, you can simplify everything in terms of s and t, which means substitute what x is. What is x? X, we got x as st, then minus 2y. What is y? Y is giving us what? S plus 2t times s. Then you have minus 4, s again, which is xt, and then plus 12y. What is y? S plus 2t. Right. So then you can now expand this. So this gives us 2s squared t, and you can bring the 2s together, right? And just have this. So I can simplify this way, okay? So minus 2s times s is minus 2s squared. Then minus 2s times plus 2t, that's minus 4st. Then we come to the next one, 4s minus 4st. We are here now. And then in the last one, we have plus 12s plus 24t. So we can simplify further. We have 2s squared t minus 2s squared. Then minus 4st minus 4, that's minus 8st plus 12s plus 24t. And now this gives us the final answer that we're looking for. So it's either you use this or you use this. So both of them are correct. Now the final part of the question is to evaluate this function z at, so let's look at it here. So we need to evaluate, so the last part, so let's do it here, is to evaluate z at s equal to minus 1, t equal to 2. So what does that mean? Now remember that what? Z is a function of what? X and y, okay? So first of all, we need to find out what x is. Remember, x is s times t. So that means that what is going to be -1 times 2, which is -2. That means x is -2. And what is y? Y is what? S plus 2t, which is -1 plus 2 times t. So that will give us 4 minus 1, which is 3. Okay, so your x is -2 and your y is what? 3. Now we need to figure out z, which is x squared minus 2xy plus 3y squared. Now, what do we, how do we solve this? So let me just zoom into that. Okay, to complete the problem, let's just focus on this. Okay, now, x squared minus 2xy plus 3y squared. So we know that our x is -2, so that will be -2 squared minus 2 times, what is x? -2, what is y? 3, plus 3y squared, and remember your y is 3, okay? So now -2 squared is just 4, -2 times -2 times 2, that's plus 4 times 3, that's plus 12. Then you have plus 3 times 9 here, so this is 9, so that's 27. So when you add this together, you have basically 16 plus 27, so that will give us 343. So this will be the value of z when s is -1 and, sorry, when s is -1 and t is what? 2, okay? All right, so that would give us the value of what? Z. So this is this last problem. Now, if you have, so a student sent this to me to solve for her. So you as well can also send me a problem that you would want to see on the channel that would help you understand the topics and the topics taught in calculus, as well as mathematical methods, the course which I'm teaching this semester. So if you want to understand things better, you can send me any problem that you're having trouble solving. By the way, make sure you subscribe to this channel, share it on your social media channels, allow other students like you to take advantage of this opportunity. I'll be posting more videos on this topic, on several topics surrounding mathematical methods later on this week. So make sure you stay tuned and press the bell button so that you get notification anytime I post a video. And I'll see you guys in the next one.